Hello everyone, welcome back to the second video of Civil 3D for Land Surveyors. In this video, we'll be covering how to draft your existing parcel data, how to draft your existing additions, and how to add survey points to Civil 3D. This video will be split into three parts. For this video, part 1, we'll be covering how to create calculated points and how to draft your legal description. So with that, let's begin. Okay, so first and foremost, we need to start opening up a new drawing and start calculating our survey monuments. So to do this, we can either open a brand new drawing, or we can go up to our folder file location here, click on this guy, and open up a base drawing, which your base drawings will have a bunch of layouts, layer types, and bunch of like presets that you made for yourself would be saved in this base drawing. But anyways, that's what we're going to do, or at least that's what I'm doing. I'm opening up this base file so that way I have a bunch of information and I can just work off of that from there. So first and foremost, I wanted to double check that this is set to the right datum, because otherwise we're going to be putting points that are going to be located somewhere completely different. So we need to make sure we're set up in the right coordinate system and we have the right datum, and so on. So this may or may not be a default setting in Civil 3D. I'm not sure. But you're up here in your home ribbon tab here, there is a tool space icon. When it's turned off, it looks like this. When it's turned on, it looks like that, right? You have multiple tabs here that are useful for many things, but we're gonna, right now it's in Prospector, I want to go down to Settings. So now this is my drawing settings. So if I want to set up the coordinate system, set up the datum, you click Base Drawing, which this will be whatever your file name is. So if you said, hey, existing conditions 1 or whatever, that's what this name will populate with, is whatever the DWG is named after. Mine's just base drawing, so it's just base drawing. But anyways, so click on this guy, right click. We have a couple of options here. We want to go to edit drawing settings. When this window pops open, we're also given all sorts of other stuff going on here. We don't care. We want to go to units and zone. So for this, we want to come down here to zone, and we want to just start filling out our information. So my project and all these videos are going to be based in Utah, so you just open this up. We're going to go to USA, Utah, and the available coordinate system, we're going to do NAD 83 datum and the central zone for Utah. So how this looks on the drop down menu here, it has all sorts of stuff here, but we want to make sure it says NAD 83 Central Zone US foot. So click that. It'll auto-populate like this code and then description and so on and so forth. So that should be all fine and dandy. You just click OK, and now we're set up in the right coordinate system. So now what I want to do is we're going to start putting our points in for our calculated survey monuments. You don't have to do this. Like, this is totally optional. When I'm doing a lot of my drafting, I like to make sure I have things set in the right spot, so I'm not having to go and like fetch all my line work and have to move it back to where everything's actually supposed to be located. So this is, you really don't need to do this. This is calculated points. But we're going to do it. But this is also useful because you might want to use this later when you're doing field work and want to calculate some points. So anyways, so we're going to go, yet again, this home ribbon. We're going to go over here to points. Click on this. Go to point creation tools. And we're looking for this guy here, has a plus mark. It's the miscellaneous manual. So we want to click that. And now, if you look down here at your command bar, like it'll give you instructions of what your current command is trying to look for. It'll also, right next to my cursor here, has a little command bar as well that is asking for instructions and giving you instructions of what it's looking for. So what we want to do, just read it. So it's asking a point. We have to specify a point to make our point. You can, if you know where to put it, you can put it. Otherwise, you just click. And now it wants a description. We're just, since this is a calculated corner, we're just going to call it, it's a section corner, so we're going to call it, whoops, make sure your caps is on, section corner calc. Whoops. Calc. You just hit enter. Specify point elevation. I don't care about that right now. We're just going to click 0. I can always enter that in later. And then boom. Here's our calculated section corner monument. So right now this has no information attached to it, so we need to start putting some information to this. So to find this information, in the previous video I told you if you go to Utah County Surveyors website and you go to the PLS corner tie sheet, monument tie sheet, or whatever they call it, you can gather all your information regarding its northing and easting. And that's what we're going to be doing here. So you click this guy, right click it, go to edit points, and now this window pops up and we can enter in its easting and its northing, as well as its point elevation, so on and so forth. We can enter a whole bunch more information into this if we truly desire. But we need the information based off of our tie sheets to fill out the northing and the easting. To start populating the point with its information here, we look at the tie sheet. This is the tie sheet for the north quarter corner of section 30, township 5 south, range 2 east. So what we do is you have your NAD 83 state plane coordinates and your NAD 27 state plane coordinates. So we're in the datum of NAD 83, so we're going to be using this information here. So for all your northing and US survey feet, it is this. And then for your easting and US survey feet, it is that. So that's what we're going to start filling in on our point. So I'm going to move this guy off to the side here so I can look at it. So our northing is 7300922.29 feet. Now our easting is 1567028.34. Cool. And as you can see, the point disappeared now. So it's gone to its correct position, or at least we're hoping it's in the right spot. Should be. But to zoom to it, we can either type Z for zoom, hit space, then E for extent, that's space bar, and then boom, it'll pop right to it. Or you can just triple click your middle mouse button in, which is your scroll wheel. Triple click that in, and it will zoom up on whatever you're drawing. In this case, all we have is the point, so it'll just zoom in on the point. So my little trick for this is, if you are curious if this landed in the right spot or not, just go to your geolocation tab up here, click this. You go map on and off over here, just click that, go to, you can do whatever you want. I'm going to do Bing Aerial. And then, bam, like, if we look right here, so keep an eye on that guy, look at this. That seems like that's where it's supposed to be. So we should be good. The only complaint I have with this method is like, yeah, we can see that it's in the general right spot, but never trust these geolocation maps. It's not going to be spot on. It's going to be, I've had stuff where like the thing is like 6 feet off, or it could be pretty off, but like it helps you get the general idea that like, yeah, it is kind of where it is. But anyways, so yeah, that's just how I double check to make sure. I'm like, yeah, that looks like it's supposed to be there. So let me just turn that back off. We can start drafting our property description from here. Okay, now that we have our calculated north quarter corner, we're going to start doing the bearing and distances for our property legal description here. This is the warranty deed that I ended up picking up in the previous video. So we're going to be following this to create the property's boundary. So this information here, which is a 716.75 feet south and 115.83 feet west from the north quarter corner, is the information I'm going to be drawing. So we're going to hop back into Civil here, and just going to tell you right now, I'm going to be reading the rest of the bearings and distances, and I'm just going to display them on screen. But outside of that, I'm going to have the rest of this off screen so I can read it, and I'm not constantly jumping between two different windows. So to begin drawing this guy, we're going to type PL for polyline, or you can go up into Home, go to your Draw tab, and then you can click this icon here. See here. This icon, which is the polyline, but if you know it, you can just type PL for polyline. And now we're going to zoom in on this. We're going to have our snap go directly to this guy. Your ortho will probably be on or off. I don't know. It just fixes its default settings. But to turn that on, you just come down here and just click it on or off, which allows you to draw 90-degree angles. Or you can hit F8 to turn it on and off. My computer, I have to hit like FN8 to turn that guy on and off. But yeah. Let's draw this thing. So we need to head due south, 716.75, and then due west, 1550.83, and there we go. That'll be our tie. Now we start doing the actual property boundary here. So you type PL, hit your snap, and then we want to go over here and look for your bearing and distance. It's BD, but you click this guy to activate it. And now we'll be working in the 4 quadrants, which is the northeast, southeast, southwest, northwest, and then 1, 2, 3, and 4 travels clockwise. We're going to be working in these 4 quadrants. So drawing this fella out. We're so lucky and fortunate enough that this legal description starts off straight off onto a curve, and curves can be tricky. They can be really not fun to draw sometimes, but as long as you have the chord bearing and the chord distance, you can just draw that and ignore the arc length, delta, and radius for now, and like you can just circle back and do it later. for the most part, in legal descriptions, the legal description is required to have 3 parts, which is the arc length, delta, and radius. They don't have to give you the chord bearing and the chord distance, even though it would be super nice if they did, but they're not required to. They don't have to do that. But when they do include it, it makes life so much easier. But anyway, we are lucky and fortunate enough that we have the chord bearing and distance, so we don't have to do a bunch of other work to get this curve. So let's begin this. So for the chord bearing here, we're going to be going southeast. So you click southeast quadrant, and then you'll type 10D for 10 degrees, and then 35 feet and 38 inches, or respectively 35 minutes and 38 seconds. Then click enter. And this is going 73.73 feet. And there we go. There's that curve for right now. And now we can just continue down the line. So our next one, southeast, is 10 degrees, 56 feet, 37 inches, 502.84. 502.84. And then on to the next. Northwest, 89 degrees, 57 feet for 335.28. On to the next guy. Northwest, 0 degrees, 32 feet, 424.38. And then northeast for 7 degrees, 34 feet, 11 inches. Or 7.24. So from here we go northeast, 88 degrees, 13 feet, 45 inches for 87.09 feet. And then we go northwest, 10 degrees, 45 feet, 09 inches for 78.88. And then we go northeast, 79 degrees, 14 feet, 48 inches for 143.14. Then we go northeast, 30 degrees, 31 feet, 49 inches, 31.80. And then it goes due east for 0.016. I'm not sure what's up with that, but I don't really care. There we go. There's that. Okay, so when it comes to drawing this curve here, there's multiple different methods you can do, but the most simplistic one is drawing circles at either endpoint and then connecting an arc based off of like an intersection of that circle. So I'll show you how to do that right now. So we want to go all the way to the endpoint, this guy. We want to make this circle as big as the radius of the curve. So for this one, the radius on this guy is 6,056. You want to go to the endpoint. Just use your snaps. If we can find it. There it is. Endpoint there. 6056. Cool. Now we have our circles out here in the middle of nowhere. According to the legal description and also looking at like a map, this follows along a road, and going along the curve here, it goes to the left. So I just want to make a circle on the intersection of these two circles here. That'll make the curve go to the left. Cool. Now we can go into here. Zoom on in. Convert to arc. Hit to this midpoint or the perpendicular. And bam, there's your curve. I'm just going to toss these because I don't need these anymore. This one's very subtle and kind of hard to see. To check this guy, if you go up to your annotation ribbon here, go to add labels. We go to, on our feature, we go to line and curve. We're going to do single segment. You can do whatever your styles that are set up here. I'm just going to leave it what my default is, and then your curve label style. You just want something that drags out and tells you all the information based on this curve. But you click add, click on your curve, and now here's all of our information. So looking at this guy, it's supposed to have an arc length of 73.73, which is this L here, 73.73. So perfect, we got that right on the dot. The delta is supposed to be 0 degrees 41 minutes 51 seconds. Perfect, right on the dot. Radius is 6,056, so we got that. That's right on there. And the chord bearing is 10 degrees 35 minutes 38 seconds. Perfect. And the chord is 73.73. So perfect. This method worked just fine, but I will say that it doesn't work 100% of the time. So that's just one method, and I can go into later details on different ways of drafting curves, but this one worked out, so I'm just going to move on. But that's how you do a curve. Now that we have our boundary drawn up here, the next step is to do all the adjacent properties as well, but for this video's sake, I'm not gonna do all the adjacent properties, so we're just gonna move on the list of stuff to do here. So first and foremost, I want to fix some of this. So I want to make sure that my layer types are all going to the correct thing. If you have a layer type for properties, you just want to use something that indicates, hey, this is the tie. I can even find mine. There we go. I want to use layers for my properties here. Just to get me within the same ballpark, I don't have to like continuously look through this huge list. I'm going to layer match my boundary to this tie here, so that way I fall within my layers, so I don't have to go through a whole list. So to do that, to match your layers, you can come up here to your layer tab here, and you can click this button here, which is match layer. So what it wants you to do is you select the object you want to match, click space, and now the other object that has the layer that you want, click on that guy, and bam, it matches it to that layer. Or, if you know the layer command, you can just say laymch for layer match. Do the same thing, select this dude, and select this guy, it matches it. Now I have that. I'm gonna look through my layers here and put my layer type on it.
Thank you, everyone. That's all the time I have for part 1 here, so I'll see you in part 2.